Let's take a look at some of the homework problems from the polynomial operations lesson. And for the very first problem, we need to identify each expression as a monomial, binomial, or a trinomial. So a monomial has one term, a binomial is a polynomial with two terms, and a trinomial is a polynomial with three terms. Now for the very first question, A, I have x plus 1. So really we have two terms. So here's x and here's 1. That's two terms. So this is a binomial. For the next question here, there's no plus or minus signs here, so this is just one term, so this is a monomial. And finally, for the third term, it turns out I have three terms here. Here's 1, here's 2, and here's 3. So whenever you have a plus or a minus sign, then you can count up the number of terms. So this right here is a trinomial. So once again, these are all polynomials, and we have very specific names for each polynomial depending on the number of terms. Okay, so for the next question, we need to state the degree of each monomial. So monomial means a polynomial of one term, right? And degree, we're basically looking at the highest power on the variables. So for the very first question, I have a 5a, and my variable is an a, and the highest power on the a is an invisible 1. So my degree here is 1. Now for letter B, I have x to the power 3 and I have a y, and on the y there's an invisible power of 1. So if I add the 3 and the 1, I get 4. So my degree here is going to be 4 for this monomial. And for letter C, notice that there's no variables on this letter C here, so the degree here is going to be 0. Later on, once we start learning about polynomials more in detail, we know that there's a variable x with the invisible power 0 there, and this 0 really represents that. And later on, we'll recognize that anything to power 0 is always 1. So this is the same thing as 10 times 1, but we can just go back to the basic explanation where if there's no variable, then the degree is always going to be 0. And for letter D, I have a to the power 2 and b to the power 2. So all I have to do here is just look at the combined powers here. So 2 plus 2 is going to be 4. So my degree here is going to be 4. And for letter E, on this x, there's an invisible power 1. So I have a 1, a 2, and a 3. So just add them all up. 1 plus 2 plus 3 is going to be a degree of 6 here. Okay, so that's it for the question on stating the degree for each monomial. For the next question here, I need to state whether or not the following are polynomial expressions. If they are not polynomial expressions, explain why not. Okay, so for this very first question, I notice that there's a positive power on the exponent there, and I have a 3x here, so there's nothing wrong with this one. So yes, this is definitely a polynomial. And since there's two terms, we can also call that a binomial. For letter B, I know letter B is not going to be a polynomial because it has a negative power, right? So for all polynomials, you need a positive power. And for letter C, this is definitely a polynomial because root 6 is just a number. And when you have a number, generally we call those polynomials, any number. So that is definitely going to be a polynomial. And for letter D here, since the variable and the power is on the denominator, this is not a polynomial. So basically all powers have to be on the numerator, right? So if the question was 7x to the power 3, then this is a polynomial. But since the powers on the denominator, on the bottom there, on the denominator, that is not a polynomial. Now for letter E, you gotta be careful here. We have a number on the denominator, and numbers on the denominator are okay, but the variable is on the numerator, and the variable has a positive power, so yes, this is a polynomial. Sometimes you might write this as 8 over 3, and then you can times that by x to the power 2. So this 8 over 3 is just a number in front of the variable, so that's totally okay for polynomials. And for letter F, this is going to be no because we have a decimal here for the power. Powers have to be whole numbers. Alright, so whole numbers are basically numbers that start at 0, 1, 2, 3, ... So there's no decimals, and the lowest power we can have is 0. And once again, if you have like x to the power 0, the degree here is going to be 1, right? So that's something that we'll talk more about later on in this course. Okay, let's continue our homework questions here. So basically, we are now continue our understanding of polynomial terms here. So if this is so polynomial expressions here. So every single term here in green, these are all examples of polynomials. And now we need to look at the number of variables for the first problem here. So I have 2y cubed plus y to the power 4 minus y. So there's only going to be one variable here, and that's the letter y. The number of terms, okay, well, let's count them up. Here's 1, here's 2, here's 3, here's 4. So there's 4 terms. Classification by the number of terms. Since we have 4 terms, we generally call that a polynomial. So if we have more than 3 terms, we'll call that a polynomial, and the degree is the highest power, right? So this 4 is the highest power, so that means my degree will be 4. All right, so 4 is the highest power there. Okay, moving on to the next one. For the variables, I have an a, I have a b, I have an x, and I have a c here. So basically, there's 4 different variables, right? So the 4 variables are a, comma, b, comma, x, comma, c. So there's 4 variables there. For the number of terms, there's 1 here, 2, and 3. So there's going to be 3 terms. Since we have 3 terms, we call this a trinomial. And for the highest power here, if I look at the a and the b, there's a 1 and a 1, right? So 1 plus 1 is going to be 2. So my degree is going to be a 2. So the 1 plus 1 gives me a 2 there. Okay, moving on to the next one, I have 25. So I don't see any variables, so there are 0 variables. Since 25 is just one term, there's only one term, and one term we call that a monomial. And the degree here is going to be 0, right? So whenever we just have a number here, numbers always have a degree of 0. We could also write this as 25 x to the power 0, and we'll learn that anything to the power 0 is going to be 1. So 25 times 1 is 1, but anyways, this is going to be the degree right there. Okay, moving on to the next one here, the number of variables here. Well, there's an x, a y, a z, and that's it. So there's 3, right? So an x, a y, and a z. Okay, the number of terms here, so this is 1 term, and this is another term, so there's 2 terms. So there's 2 terms, then this is a binomial. And, oops, I spelled that wrong. Sorry. This is B-I-N-O-M-I-A-L. Okay, so there you go. There's a binomial there because there's 2 terms. And in terms of the degree here, we've got to be careful with this one here. Let's just look at the powers very carefully. I mean, there's a 1 here. So if I look at the 3, the 1, and the 5, that's going to have a degree of 9. Over here, there's a 1, so there's a 2, a 1, and a 4. So if I add that up, I get a degree of 7 there. So it turns out that 9 is the highest power here, so my degree is going to be 9. Okay, let's keep on moving along to another table question here. So I need to complete the following table for the single variable polynomials here. So just another question where we can practice some of our polynomial vocabulary terms. So my leading coefficient, so the leading coefficient right here is generally the power in front of the number in front of the variable with the highest power. So my leading coefficient here is going to be 1. The constant term is generally the number, so there's a plus 13, so my constant term is 13. My degree is going to be my highest power, so that's a 4. And this is something that you'll learn a little bit later on in future math classes, but if you have a degree of 4, it is a polynomial, but more specifically, we call this a quartic function. And that's just for general interest. You don't need to know the names for specific polynomials for this class. Okay, let's move on to the next one here. So let's go to the leading coefficient. So the leading coefficient is going to be a 0.2. So that's going to be a 0.2. The constant term is going to be the last term here, which is going to be negative 0.5. The degree is the highest power, which is going to be 3. And since my degree is 3, we call that a cubic function. All right, so cubic there is just for general interest. Now for the third example here, I'm going to rearrange this as negative x to the power 5. Let's put the variables first, plus this root 7. Okay, so what is the leading coefficient? The leading coefficient is just the number in front of the variable there. So there's a negative sign there, so that means my leading coefficient is negative 1. The constant term is going to be the last term, which is root 7. And my degree here, well, since there's a 5 here, my highest power is a 5, right? So my degree will be 5. And just for general knowledge here, a degree of power 5, we call that a quintic function. And once again, that's just for general knowledge there. And finally, let's move on to the next one, pi x squared. So my leading coefficient on the x squared term is the number pi. So my leading coefficient here is pi. And the constant term is going to be, well, let's just rearrange this to be pi x squared minus 3x minus 7. So if I rearrange it with the variables front and the number at the very end, that means my constant here is going to be negative 7. Okay, and my degree here is the highest power, which is 2, so my degree is 2, and this is called a quadratic. Okay, finally, let's move on to the next one here. So negative 1 over 10 here. So it turns out that my leading coefficient is just the number, which is negative 1 over 10. There is no constant term here, but you know, you can take none. There's no constant term because there's only one term, but you know, we can also leave the constant term as just a number here because we just are given a number here. So negative 1 over 10 is considered a constant number. The degree here is 0 because it's just a number here, and when you have a degree of 0, we call this a constant function here. Okay, let's get on the last one here. I have 9x plus 12, so my leading coefficient here is 9. My constant term is the number here, which is 12, so 12. My degree is the power on the variable. There's an invisible 1 here, 9x to the power 1, so my degree is 1. And when we have a degree of 1, we call that a linear function. Okay, so in the Math 10 curriculum, we will generally look at constant and linear functions. And when you get to the higher grades, you'll learn more about the cubic, quintic, and quadratic functions there. Okay, so move on to question number 13 here. We need to simplify here. Okay, so not bad. So here we get into a few more arithmetic operations here. So I have a 6p here and I have a negative 2p. So let's combine those terms there. So 6p minus 2p is going to be 4p. Okay, and then I have a negative 7q and a negative 3q. So negative 7 minus 3 is going to be negative 10q. Okay, and that right there is a binomial because there's two terms. Okay, moving on to the next one here. I have a 1/2 x and a plus 3 over 2x. So think about 1/2 as being 0.5 and the 3 over 2 as being 1.5. So if I add 0.5 and 1.5, I get 2, so it'll be 2x. And negative 3 and plus 18. So think about that as 18 minus 3, which is going to be plus 15. And that's it. Let's move on to the next one here. So I've got to simplify the following polynomial expressions by collecting like terms. Okay, so whenever you have these brackets and there's a plus sign in the middle, you can just remove the brackets. So we get 5a minus 9b minus 2c. And then plus c, and then minus 7b minus 3a. Okay, let's go ahead and collect like terms here. I have a 5a and a negative 3a, so that's like 5 apples minus 3 apples, which is going to be 2 apples. And then I have a negative 9b and a negative 7b, so negative 9 minus 7 is going to be negative 16, so negative 16b. And now we have negative 2c plus c, right? So negative 2 plus 1 is going to be negative 1c. Okay, so that's a correct answer. You can also write this as 2a minus 16b minus c if you like. So you don't need to write the 1 there. So just write that as minus c. Okay, let's keep on going along. So now we have the next one here. So now we have a situation where things are stacked vertically, and when things are stacked vertically, we could write this as 7x squared plus 2x minus 1, and then there's a minus sign, so I can put the minus sign over here like that, and then we have the bracket negative 5x squared minus 3x minus 1. Okay, so I'm just going to write out the question horizontally like this, because now we see I have a minus sign there, and this question is a little bit different. We have a minus sign because the minus sign actually distributes into the brackets there, giving you a positive 5x squared. And then this minus sign distributes over here, giving you a positive 3x. So a negative times a negative is positive, and a negative times a negative here is going to be positive 1. All right, and then on the left-hand side here, we can just remove the brackets like the previous question. All right, and there you go. All the brackets are gone, and now we can just collect like terms. So I have a negative 7x, sorry, I have a positive 7x squared and a positive 5x squared. So 7 plus 5 is going to be 12, so 12x squared. And then I have a positive 2x and a positive 3x, so that's going to be positive 5x. And now I have a negative 1 and a plus 1, and that just cancels out. So my final answer is 12x squared plus 5x. And just for general learning, this is a binomial because there's 2 terms, and my degree is 2. Okay, so hopefully those operation questions weren't too bad there, and we'll do a few extra questions here just to kind of finish up this homework guide here. So the next question here, we have a triangle with a perimeter of 6m plus n. One side is 2m minus 3n, and another one is 3m plus 2m. So if you have a triangle here, triangles have 3 sides, and basically we know that one side is going to be 2m minus 3n, and another one is going to be 3n plus 2m. And I don't know what this third side is, but when I add up all 3 sides, then we get the perimeter of 6m plus n. Okay, so let's see if we can put this idea together here. So basically, the perimeter of this particular problem, it tells you that the perimeter is 6m plus n, and that's really equal to all the sides added together. So there's a 2m minus 3n, and then we have the plus 3n plus 2m. So maybe I'll just erase this and put this in green here. So this is 3n plus 2m. And then we have the plus the question mark, right? So we're going to figure out what that third side has to be. Okay, well, let's start collecting like terms here. I have a 2m and a 2m. So if I combine those 2 like terms, I get 4m. And if I combine this negative 3m and this negative 3n and positive 3n, that just cancels off, giving me the plus question mark left, and I have the 6m plus n on the left-hand side there. Okay, so let's see if we can figure this out here. I have a 6m and there's a 4m, right? So the question is, what do I have to do to this 4m to get to a 6m? Okay, well, I need to add an additional 2 more m variables, so I need a 2m. So this right here will give me the 6m, right? Which matches up with that 6m. And then finally there's an extra 1 n variable there, so I need another n variable over here, so let's just add another n variable there. Okay, and there you go there. Basically what we need to add to the problem now is this part right here. So if I add the 2m plus n to this problem, then that will be my third side. So my third side is going to be a 2m plus n, and I guess this is all measured in centimeters. Okay, so that's my third side. And for part B, I'm just going to erase all this. Part B, it just kind of tells you that determine the measure of each side when m equals to 4. So m equals to 4 and n equals to negative 1. So if I just go back up here, we know that m equals to 4 and n would equal to negative 1. So now we've got to figure out each side here. So let's just take this m here and multiply it with, whoops. Okay, so basically we take our m and we take our letter n there and we just plug them in. So basically for this part right here, there's 2 times 4, which is 8, minus 3 times negative 1, and that's going to equal to 8 plus 3, which equals to 11 centimeters. So one of the sides will be 11 centimeters. And then all we have to do now is we just plug in the variables, negative 1, and this is going to be 4, right? So A little bit of work here. So 3 times -1 is -3. Plus 2 times 4 is going to be 8. So -3 plus 8 is going to be 5. So 5 centimeters is another side of the triangle there. And over here, we know that m has a value of 4 and n has a value of -1. So if I multiply that out, I get 8 minus 1, which equals to 7. So 7 centimeters will be the final side. Okay, we're almost done here. I think there's one more question here at the very end here. So this question had a lot of vocabulary, but there's also some operations as well. So if this polynomial is written out like this, the degree is the a variable, the leading coefficient is b, and the constant term is c, and we need to find this particular expression right here. Okay, the very first thing we have to do is we have to rearrange this with the highest powers first. So the highest power I see is this negative 5x cubed, and then the second highest power is this positive 2x squared. And then we have the minus 7x, and the constant always goes at the very end. So the constant there is plus 4. So we got to rearrange that. Okay, so my degree is going to be a, right? So when I look at this expression here, my degree is going to be 3. So a gets assigned the degree, so a equals to 3. The leading coefficient is b. Okay, so my leading coefficient here is now -5, so b takes on -5. And finally, the constant term is c, right? So here's my constant term, so c equals to 4. Okay, and now finally, for this particular problem, we need to evaluate 3a minus 2b minus c. Okay, so we know that the a has a value of 3, right? So this would be 3 times 3 minus 2 times b, and b has a value of -5, so let's put the -5 there now. And then we have the minus c, and c has a value of 4. Okay, and now we just got to calculate this. 3 times 3 is 9. 2 times 5, they're both negatives, so that's going to give me a positive answer, right? So positive 10 and then minus 4. 9 plus 10 is going to be 19, and 19 minus 4 is going to be 15. So my final answer there is going to be 15.